So problems continued, sadly. What is wastewater?
Sewage water.
Sewage is a good word to describe. What else? Or what is sewage water? Or what is wastewater? Huh? Gray water. Good job. Add that word to your notes because you need to know it. Tomorrow you're going to do a home water audit, and it talks about gray water, which is what? Still not telling me what the definition is. Gray water is what? How does gray water form? Give me an example. No. Considered polluted water because it's filled with toxic chemicals, right?
Doesn't gray water refer to anything that's like being used to wash dishes or showers, but then wastewater would be anything that has sewage in it?
So the gray water ends up being wastewater, right? Water that's used in your home from washing hands, washing dishes, taking showers that you use that's kind of left over that becomes wastewater. So gray water becomes wastewater, which leaves your home, and we're lucky because it goes to sewage and gets treated, right? But not all water or all wastewater gets treated. So obviously the problem with that would be that a lot of water that's being used ends up wasted, and instead of reusing it, it goes away, right? Or goes out of the cycle. So this is eutrophication, which we talked about when we talked about biomes and water, aquatic biomes. This is actually Miami Beach, okay? Because remember, this was a big topic for us this summer. And you have to know every single step of this process, the consequences of the process, and it's all over your exam. So be very, very careful in making sure you know these steps. So this diagram, we're going to follow the diagram. 1, 2, 3, 4, 5, 6, 7, 8. It's 2 pages, okay? And there's alternative problems to this. So 1, 2, 3, 4, 5, 7, 8 is one problem, and then 1, 2, 3, 4, 7, 8 is another. Okay, so I'm gonna organize it for you. But what is the triggering of cultural eutrophication? You learned this last chapter. Runoff of what? Fertilizer filled with and phosphorus. So nitrogen and phosphorus found in fertilizer, that's 1 and 2, right? We're pouring fertilizer to fertilize plants, especially in the agricultural society or industry, in excess can't get used up by the plants fast enough or can get washed away, which would run off into a large body of water. And what's happening in 2? To the fertilizer or to the nitrates. It's going into the ground, leaching into the ground or infiltrating, right? We call it leaching because infiltration would be water going into the ground. Leaching is water taking the nitrogen and phosphorus with it into the ground, which will end up in the body of water. So you either have runoff or leaching, and then what happens? Algae blooms. Algae forms in overpopulation of algae, which means you're going to have a lot of algae in an area that shouldn't be there. So some people ask me, is this like an invasive species? Invasive species usually don't overpopulate in an area. It's 1 or 2 and eventually can lead. So they don't thrive like invasive species do because they don't belong there and there's too many of them. And that means their resources are limited, right? Because they don't belong there. But if we go 1, 2, 3, 4, we have algae bloom. What's happening with 5? It's blocking sunlight from penetrating or reaching the bottom. And let's say this was the intertidal zone or the coastal zone of the ocean. We know there's a lot of plant life there and they're not able to do what? Photosynthesize, which would cause the plants to die, okay? Did 1, 2, 3, 4, 5, and you have death at the end, okay? The reason the algae dies or the plants die and then this happens is because plants can't photosynthesize, which means what's going to happen? They can't produce food and they die. Shh. What else doesn't get produced? Oxygen. So levels of oxygen drop, and if there's no oxygen, our fish are going to die. So from 6, you could say we could go to 8. Does that make sense? Okay. So we have 6 here. And 8 can happen, 7 and 8 can happen. Less oxygen, whatever. Okay. 8. So 6 to 8. Now, before number 7, we have 1 through 4. So I'm going to repeat that. We have nitrogen and phosphorus, runs off, algae blooms, and now comes 7 and 8. After the algae blooms, because it's overpopulated, what can happen to the algae? When an organism is overpopulated, what happens? I will pause. Overpopulated algae means algae is limited with its resources. So eventually the algae dies because they don't have resources to meet their needs. And the algae, because it's organic matter, like you learned yesterday, requires oxygen-demanding bacteria to break it down. And that oxygen-demanding bacteria will reduce the levels of oxygen in the body of water and cause fish to die. So regardless, when you have eutrophication, you're going to have levels of dissolved oxygen dropping and fish dying in the end, no matter which route you take. Why do you think it's hazardous to go in the water? Like, our concern wasn't that fish were dying and that the algae was overblooming. Our concern was toxic chemicals. Where are they coming from? Nope. Good. The decomposition process in general leads to this bad smell, right? You know, it's a smell of death, really, or sulfur and all these compounds being, and also, you know, think about if you're swimming and you swallow it. It's not like it's deadly, okay, but it's just not healthy. So that's why the people were warning you not to get in the water. What's thermal pollution? What do you think of when you see the word thermal? Heat. Good. And I put degrade water because I want you to really realize that degradation of water, degradation of a resource, which we talked about in Unit 1, means you're taking it to a state where it's no longer at its best, right? If you heat up water too much, it actually causes dissolved oxygen levels to drop. So like eutrophication, where dissolved oxygen levels drop, warming water causes levels to drop too. What's the main contributor to thermal pollution in a body of water? Electric power plants. Nuclear or coal, if they're surrounded or if they're right by a water plant, they dump the water back into the ocean or back into a lake, wherever they're getting the water from. Industrial plants do this as well. On the test, I want you to focus on the fact that the main cause is electric power plants. You want to know that it lowers dissolved oxygen, right? You don't really have to know these, but I want to talk about them for a minute. Who could tell me, why do you think deforestation can lead to thermal pollution? Because these are actually new topics that kind of are tied in. And at the end of the day, we know this is a big problem in our world, deforestation and erosion. And both are leading to the warming of water. So try to make that connection. Who can make it for me? Good job, Olivia. Deforestation means less carbon dioxide being circulated, which means more global warming, which means warming of water. In addition, you can have, when you cut down forests provide shades for body of water, and those shades will no longer be there, so the water gets warm. How about erosion? All right, so you know this is not on the test, okay? Neither is this. I want you to focus on electric power plants being the main cause of thermal pollution, because it is really a big contributor. All right, floods, big problem. They are very naturally occurring, okay? Because at the end of the day, when it rains in excess, it's going to flood. But we want to recognize that because of global warming, we have extreme weather. And that extreme weather can lead to periods of drought or periods of heavy rainfall or 40-degree weather, right, for significant amount of hours, which is not considered winter. It's just 40 degrees, right, for one day. That's what we have right now, extreme weather. But also, global warming is going to cause what to rise? Sea level, so that could cause flooding as well. Another contributor to flooding is the fact that we're clearing water-absorbing vegetation, like what? What's this a picture of? Mangrove forests. Like, look at their roots, deep down, absorbing water, taking it in, making them thrive. Same thing with any kind of wetland. And we destroy them, which can lead to increase in floods. I'm taking you back to Unit 1, because at the end, we talked about all the problems when we started this class, and then we talked about solutions, right? Now we're going to learn about each problem and obviously end with solutions, because we need to have these. If ever you get a question on the AP exam about a solution, prevention is the answer. Prevention is the number one solution to every environmental problem. How many of you can tell me one example of prevention that you used yesterday? So prevention could be laws that regulate from you doing something that can lead to a problem, or laws that, what'd you say? Or discourage or punish, but you said something else, that it wasn't to regulate, but to, okay, I forgot to. But think about this, when you're asked for solutions, you usually come up with a cleanup over prevention. And the same thing with the problem. If you ever get a question on the problem, the number one reason for all environmental problems is what? Overpopulation. The solution is prevention. Don't forget that those are always going to be your choices. In your book, I'm going to jump over here. There's these, I can't stress this enough. If you're going to use your book, this is the time. There's these diagrams, and they're going to use a lot of examples of prevention versus control. Okay, reduce, reuse, recycle. Reduce is the prevention. Reuse would be recycle is the solution, right? Because we've already used it. So figuring out ways to make things better, okay, to limit the way we use things, okay, limit the way you use things, or limit waste, or improve systems or efficiency. That's prevention. Efficiency. Okay? Now I kind of jumped here, but I want you to just, before we start solutions, I want you to realize that as overpopulation is the main cause, because of urbanization, we are affecting the flow of water. So we're decreasing infiltration and evaporation, and we're increasing surface runoff, which is our reliable runoff. We're decreasing our reliable runoff, which comes from watersheds, right? We're building roads. Roads prevent water from infiltrating or naturally running off. So it's affecting the reliable runoff. So our whole water cycle is affected. Urbanization is the last problem. So these slides should be swapped. You should go from floods to urbanization to then prevention, where we start solutions. Okay? The mangroves is a problem. So flooding is a problem that's mainly caused by natural, right, or global warming or removing of mangroves. And then comes urbanization, which will also lead to problems with our water. And then we start prevention.
So urbanization before?
Yes.
Then mangroves are after?
Mangroves are part of flooding. Let's do this again.
Oh, okay, I get it.
Okay, you got flooding, naturally occurring, caused by global warming, caused by removing of mangroves. Last problem in the list is urbanization. Biggest problem with urbanization is that it's decreasing our reliable runoff, decreasing our infiltration, which will lead to runoff, okay? And then we got to talk about the solutions, right? And our first solution is to reduce consumption, okay? We also have to, we're not going to stop using water, okay? And I could give you this example. This is from your book too. The number one way they said we could stop using water was to raise water prices. People used to pay I'm the people, ask your parents. We used to pay water every 3 months, and you would pay $25 or $30 every 3 months. Anybody know how much you pay for water now? $200. How often? A month. $100 and something to $200 a month. That happened in 20 years. So this idea, they realized was a good one, except they didn't realize that we still need water and we're still going to use water. We're just going to have to figure out a way to pay more, right? Because they did that to try to reduce the use of wasted water. Reducing would be getting better shower heads. So when you take a shower, the water hits you instead of hitting everywhere else, right? Sprinkler systems that irrigate your lawn instead of wasting water. Not using water at specific times of the day. These are the things we want to think about. And I'm going to leave you with that because we'll talk more about those tomorrow.